So, hi guys, hopefully no different to a normal lesson. We're going to have a quick look at 410. It's basically GCSE physics. All of the ideas in here, bar 2, were used extensively in the wave section of GCSE physics. Those two ideas I'm going to focus on the most are phase difference and the word displacement. So let's have a look. A wave is a transfer of energy as a result of oscillations of a medium. Dead easy. Just learn it. The key thing is the two types and how to differentiate between the two. You'll notice we refer to the direction in which the oscillations are compared to the direction of travel. So in a longitudinal wave, the oscillations are parallel in the same direction as travel. You can use those two phrases. That's how you describe one. Transverse, opposite way around. Transverse, the oscillations are at 90 degrees to the direction of travel. In a Mexican wave, you go up and down, but the wave will move around the room. That's a transverse waves. Just make sure that you learn to talk about parallel, perpendicular, same direction, 90 degrees. That terminology must be used. This book is all about how we measure waves and how we compare and look at and talk about them. All of these quantities, except displacement, you will have heard of before and used at GCSE all the time. Learn the definition for each one. So maximum displacement is probably a new way of describing amplitude. The maximum displacement of a point on the wave from the equilibrium position, that's really important. The wavelength is the distance from any point on the wave. It can be any, it doesn't have to be peak to peak. That's an old, get that out of the way. Don't say peak to peak anymore, that's a GCSE definition. It's the distance from any point on the wave to the next subsequent point in phase. You might not understand what that means right now, doesn't matter, that's what the rest of this video is about. The next subsequent point in phase. Speed is speed. Frequency, the number of oscillations per unit time. The unit of frequency is the hertz, which is a special name for the per second. One oscillation takes the time period. The one that you're going to have questions about is displacement because it's new, but hopefully it's not that weird a concept. If a wave wasn't there, all the particles on that wave would lie on the equilibrium position. That's the straight line that we draw. Maybe you want to call it the x-axis through the middle of that wave. The displacement is just how far is this particular point, any one that you want to talk about, how far is this point from that equilibrium position? So your amplitude might be 0.5 of a meter, but your displacement might be 0.25. That means you're halfway up towards the amplitude. We can have a negative displacement as well if we're below the equilibrium position. So if your amplitude was minus 0.25, you would be a quarter way to the amplitude but below the equilibrium position. You'll get used to it, it's not a big deal. It's phase difference that we're going to talk about.